All right, Mr. Farmer here, and today for AP Microeconomics, we're continuing our conversation on perfectly competitive markets. Focus on efficiencies, productive and allocated efficiency, and then also how can these cost curves shift as well. All right, so first thing you want to do, just kind of practice. So I have three different prices, PA, PB, and PC, and there would be a supply and demand industry graph next to us, but I want you to practice. At PA, will they produce in the short run? Answer, yes. They're producing at a profit maximizing MR equal to MC, because demand is equal to price, and demand is equal to marginal revenue in perfect competition. So they're producing at a profit, and in the long run, firms would enter into the market. Okay, next we have PB. Will they produce in the short run? Answer, yes. This is called minimizing loss. They are profit maximizing is going to be occurring right here. So they are below their average total cost curve. So they're losing money, but they're going to lose less if they continue to produce because they're able to pay off all the variable costs plus push a little bit into paying off part of those fixed costs. We call that minimizing loss. In the long run, yeah, firms are going to leave, and the firm that we draw here we'd assume would stick it out, and so that they're going to be representative of the firms that stay in. Last one, PC. Will they produce in the short run? No. This is shut down, and so it's a quantity of 0. They wouldn't produce anything. The profit maximizing, if there was a quantity, would be right here. Quick note, sometimes you see the marginal revenue crosses 2 separate times. Can I give you a hint? Go with the later one. Just trust me on that. That's your answer. So they're not going to produce at PC, and in the long run, they're definitely going to leave. And once again, the firm we're drawing, they're going to miraculously stick it out and will represent them. Okay. So let's talk allocative versus productive efficiency. I talked very quickly at the end of the last video about this, but let's just make sure we know our definition. So allocative efficiency is the idea that a market is allocatively efficient, meaning producing at the socially optimum output when the consumer and producer surpluses are maximized. Another way to phrase this is a market is allocatively efficient if no deadweight loss exists. So this occurs functionally when the supply is equal to our demand curve. Now we can sometimes use our marginal cost curve as a substitute. I'm going to go over that in just 1 second. So here we are, socially optimum, and look at that. Our marginal cost curve, which is going to become our supply curve in a second, is equal to our demand curve. For productive efficiency, a market is productively efficient when the firm is producing each unit at the highest efficiency. This occurs when they produce at the lowest minimum average total cost. Production should always occur at profit maximizing. And so if you're profit maximizing at that quantity, you are good to go. There we go. I had to move that around. Okay. Hence why this is called perfect competition. In the long run, perfect competition is both allocatively efficient. We have our supply equal to our demand curve. And they're productively efficient because they're producing MR equal to MC at the break-even level. So their demand is equal to the average total cost. And since they're in perfect competition, your marginal revenue is equal to your demand curve. So you can put all that wonderfulness together and you identify that you're producing MR equal to MC at the minimum ATC, average total cost equal to marginal cost. Yay! So they're perfectly competitive. Again, this is not going to be true for the imperfect markets, which is why they're called imperfect markets. Okay. So how can we use this marginal cost curve as our supply curve? Well, think about this. I have a graph over here. Where would be the minimum that they would produce at? What price, what marginal revenue? I'll give you a little hint. There's a shutdown point listed on here. So the idea is that below P2, they're going to stop producing. And so the marginal cost curve in combination with the marginal revenue curve tells us at that price, they would produce that quantity. And so because it gives us this information, sometimes people use the marginal cost curve above the AVC as your supply curve. So for perfect competition, we have a supply curve with the market supply. But later in perfect competitions, we don't actually have the industry graph to go along with. So we get to use it as such. Okay, so cost curves. So let's give an example. Let's say there's an increase in productivity through things like through training. Well, then the average variable cost curve is going to shift because now each of those workers are going to be faster producing their stuff. So that standard wage, whatever they're getting, I keep using $10 as my example, that $10 per working unit now can produce that much more. So if the average variable cost curve shifts, then the average total cost shifts, since average fixed plus average variable equals average total, so we have that shift. And if my total costs have shifting, I've actually talked about how if my variable cost shifts, then my marginal cost would have shifted also. So all these have shifted down, kind of down into the right is going to be an increase in productivities, typically speaking. So this means that the short-run cost curves, yes, they can absolutely change. And so now here we have our new settings. Okay, so that supply curve would definitely shift. So what does it look like before when we just had our supply curve? Well, there's a new technology that increases productivity. Previously, when we just had this industry graph, we'd show an increase in supply, which would mean there'd be a decrease in the price and an increase in the market output. We've seen this before. But what's it look like on our new cost curves? Well, this would also be seen on the cost curves. Those costs, as we just talked about, are going to decrease, are going to shift. Now, where's the demand curve? Well, demand is based off of the price, and so we carry that all the way across, and so the demand is going to be down here. Okay, so at this new price point, this is the new price for this market. Again, that's dictated by the industry. One thing to note is these do not guarantee break-even points. This is why College Board doesn't typically ask about these, is because you don't know the magnitude of the shifts. What could definitely be asked about is, one, what's happened to the price? No matter what, the price is going to decrease. Two, what's happened to the market output? Well, the market output's increased. What's happened to the firm output? Well, that's also increased. But I can't actually say for certain if I'm producing at a profit, loss, break even. I don't actually know what this is. Okay. So the firm in the industry, quick little note that you may have already seen is that, again, the supply curve, the industry supply is the sum of the individual supply curves added together, and here we have a representative firm. So if I tell you each individual firm produces 10 units and the entire industry produces 200, well, how many firms is this industry? 20. 10 times 20 equals the 200. So again, these are representative, and we assume they are identical companies, hence why their cost curves can be replicated in this way and everything else. So there you go. So you can definitely practice some things that would prove, sorry about that noise, that would go into this. So create two scenarios and draw them. A situation that would increase the marginal cost, a situation that would decrease the marginal cost. Just kind of see if you can come up with something. Just kind of quickly pause the video and see where you're doing. What you should have come up with is changes in a resource price, changes in technology, changes in regulation, potentially. That could definitely work. All these things are going to change the ability to produce goods. And these are all things that could happen in the short run. Change in resource prices, variable inputs or resources. Change in technology, you get a little iffy as far as like if that's a long run or short run because it changed fixed capital. So we kind of put that one to the side. That's just going to be a context question though. So these are things that can definitely shift the ability to produce the goods, which then shift the curves as well. So for my class, we're going to hand out a worksheet, but for everybody else, what I want to do is just kind of go through how I go about drawing these graphs. This isn't like an academic thing. This is just, I found this to be the easiest way of drawing these. So I first start and draw my industry supply and my demand graph. I'll then label that, my price, my market output, QM. I always put QM for the market. There's a lot of I, so I don't put QI. That's just a personal preference. And then I'm going to go ahead and carry that price all the way across. Again, this is indicating that they are a price receiver or a price taker. And then I just put the Mr. DARP over here. You actually just need your MR and your demand, but if you want to put Mr. DARP because it's just stuck in your brain, just go ahead and put all that down there. And my price is over here. Once I've done that, the next thing I'm going to do is I'm going to put my marginal cost curve on there. And just kind of do a general check mark is fine. Once I've done that, I write down my firm's output. The reason why is everything else is based off of this. This is the starting for every single graph for perfect competition. And again, I'm labeling it QF because these are not the same market outputs. This is the market of like 200, for example, and this is the firm output of something like 10, and those are not the same number. Now, if you're told, oh, they're breaking even, then after I do my base, I can go, all right, so they're breaking even. So my average total cost needs to be equal to my demand curve at this quantity. Or if I'm told, oh, they're producing at a loss, okay, then at this market output, I know that my demand needs to be less than my average total cost. And if it's a minimizing or shutdown, you include your average variable cost. If it's ever a loss, you do need to put in the average variable cost to identify minimizing for shutdown. Or if I'm told, hey, they're actually producing at a profit. Great. Then after I've drawn all my curves, then at the profit maximizing, which would be right here, then I know that my price needs to be above my ATC. Great. So I start with that. So again, not an academic thing, but I definitely think that is a good way to do this. All right. Hope that helped. Until next time.